Hi everyone, in this video we'll be learning more about the properties of a row echelon form of a matrix. So I'm sure some of you might have already wondered, what does it mean by a row echelon form? Well, in my videos I've done what I've covered. I've already done this, but I think some of you might have asked me, what does it mean by row echelon form of a matrix? So let's go through in detail what this means. Let's go through the first property first, where all the leading entries in each of the rows of the matrix must be equal to 1. Cannot be 2. Sorry about that. It cannot be 2. It cannot be 3. Cannot be 0. It must only be 1. So as you can see, the leading entries in each of the rows are 1. So if the column has a leading entry, which is 1, then all the entries below the leading entry are 0. As you can see here, for the first row, 1 is the leading entry, and below, zeros are all the entries. And the same for this, for the second row, 1 is the leading entry. So, zeros are all the entries below 1. And for the third row, it's also the same. 0 is the entry below 1, which is also the entry below this leading entry, and this same goes for this. So we have already gotten, so as you can see, if this is the form of a row echelon form, so you get 1 1 1, let's say 1, then 0 0 0 0 0 0, and this can be your integer, any form of integer here. So we have, this is an example of a row echelon form as described by here. So now this we have already satisfied property 1 and property 2. So now for in any two consecutive non-zero rows, the leading entry in the upper row occurs to the left of the leading entry in the lower row. So as you can see over here, in every row, 1 is the leading entry. So as you can see, let's do it in another color. So for 1, for this case, 1 and 1, you can see that on row 1, 1 is to the left of the leading entry of 1 in the lower row here. So 1 is on the left side of here, and the same goes for this row 2 and row 3 also. For here, row 2 and row 3, 1 is to the left of the leading entry in the lower row. So like as you can see this example here, 1 and 1, so 1 is to the left for the upper row, 1 is to the left of the leading entry in the lower row, and the same goes for this and this. And now this condition is satisfied. How about this one? Now let's use another ink. All rows consisting entirely of zeros, should there be rows, this means that if there are rows there are rows entirely zero. Zeros. So the keyword is entirely. So here, as you can see, it's entirely zero. So this last one is only if there are. So take note of this, number 4. So as you can see, this row is entirely zero and it appears at the bottom of the matrix. Unlike this one, where there are no rows of entirely zeros, but this is still a row echelon form because it satisfies the first 3 properties. So now we can say that this is indeed a row echelon form of a matrix, and this also. So we have now come to the end of this video where we have already covered the properties of a row echelon form of a matrix. In our next video, we will cover the properties of what defines a reduced row echelon form of a matrix. That's all for today and have a nice day.